In this video, we're going to look at an alternative way to factor. It's called without the area model. So we've already looked at how we can factor using the area model, but there's a way we can do this using guess and check. So we're going to use factor this first one here, x squared plus 8x plus 15. Now, with the area model, we can draw in our boxes here. And we know the first term is x squared. We can put that in there. We know the last term is 15. We'll put that in there. And then we're looking for the combination that will give us 8. Now, effectively what we did is we guessed to figure out what could go in the area model. Well, we'll call it strategizing and not guessing. But essentially what we did is we tried to figure out what could potentially go there and see if it worked. We're going to do the same thing, but instead of using the area model, we're going to try and do it without it. The area model is just a way to organize the information. So I'm going to go ahead and get rid of this. Now, again, at the end of this lesson, if you're still like really dead set on the area model, then please go ahead and use it. It is a valid method to factor. So first thing I'm going to look for is that first term, x squared. I want to know how am I going to get x squared. The only way I can think of is to take x times x. And then I'm looking at that last number, 15. So I'm going to analyze a little bit before I jump into guessing some numbers. I know that that last term there is positive, which tells me that both of my factors will have the same sign. The middle term is positive as well. What that tells me then is both factors will be positive. There's no way for both factors to be negative and end up with a positive number in the middle. So I'm thinking of numbers that could multiply to 15. Again, my strategy was, let's pick the numbers that were closest together when we're dealing with the factors. So 15 could be multiplied to give, 1 and 15 could be multiplied to give us 15, and also 5 and 3. So the factor combination that's the closest is 5 and 3. So I'm going to go ahead and see if those work by putting in a 3 and a 5. And the way I'm going to check it, if you remember the area model, we looked at kind of that diagonal piece to see if they added up to the middle term. We're going to do the same thing, but in a different way. We're going to look at these terms here. So 3 and x gives me 3x when I multiply those. And I'm going to do another one here. 5 times x gives me 5x. And when I add those up, I end up getting 8x. So that is my right combination because those x terms add up to be 8x. So that's my factor, x plus 3 and x plus 5. If I use the area model, I get the same thing. And in number 2, it's a little bit more challenging for a couple reasons. The first one is the fact we have a 2 out in front. And the other is that negative 4 on the very end. Now, the fact that we have a negative number tells me that my factors are going to have different signs. One will be positive, and one will be negative. The fact that we have the 2 makes things more challenging because it does make a difference where we put the other number. Like in the first example there, we had the 3 and the 5. It didn't matter if I put the 5 first and then the 3 because they were both across from x's, so it didn't really make a difference. Here it does. So I'm going to first start with that 2x squared term. And I want to know what can multiply to give me 2x squared. Well, I think we can do 2x and x. If we follow the strategy of using the factors that are closest together, if I'm looking to multiply negative 4, I would first start off with negative 2 and 2. And we'll see what that gives us. Well, that'll give us a negative 2x. And that's a 4x. And so when I add them together, I get 2x. That's not the combination I'm looking for because I want my middle term to be negative 7. So I'm going to have to adjust this. So instead of using 2 and 2, I'm going to try 4 and 1. So I'm going to fix that right there. And erase that one. So let's use a negative 4 and a positive 1. Let's see what happens. This gives us negative 4x, and that's a 2x, and when I add those together, I get negative 2. Okay, that's still not the combination I'm looking for. I want it to be negative 7x. All right, let's try something different. Let's switch them. Let's make that a 1 and that a 4. Let's see what happens. So I multiply these together, I get negative 1x. I multiply those together, I get 8x. I add them up, I get 7x. Almost what I'm looking for, but not exactly. It's really, really, really close. So what I need to do, though, is make that a negative 7x instead of a positive 7x. So the strategy on this, it's the same when we did area model. I'm just going to switch the signs. So instead of having a negative 1 and a positive 4, I'm going to make this a positive 1. And I'm going to erase this and call it an x minus 4. Now it'll work, because I'll have negative 8x, positive x, and those add up to negative 7x. So that is my right factor combination. Let's look at number 4, because again, same type of challenge on this. I'm going to approach things a little bit differently here. So when I first start off, I'm looking at these numbers here, and I'm seeing that I have a 3 out in front. Again, a prime number, so I know I'm going to start with 3x and x. And for 15, again, negative number, they're going to have opposite signs. So I'm going to make sure that I've got one positive and one negative. And I'm thinking that my best choice is probably a 5 and a 3. And I'm going to be smart about where I put these numbers. I'm going to put the 5 here and the 3 here. There's a very good reason that I'm doing that. I don't want to put the 3 together with something that's already got a common factor with them. You'll see in the next video that we're going to look for what's called the greatest common factor. If we have a common factor within those parentheses, we probably did something wrong, or we forgot to pull out a greatest common factor. But we haven't seen anything with a greatest common factor yet, so we know that that's not going to be a concern yet. But if I look at what I have left, I know I'm going to have opposite signs. I'm just going to kind of leave it as is right now, because I want to figure out what the signs are in a little bit. Because I don't want to do all the work and then find out, oh my gosh, I just switched the signs. So I'm going to multiply these right here and make it a 5x. And those give me a 9x. So what I'm trying to do is figure out, can I get a negative 4 out of those by adding or subtracting? Essentially subtracting, because I know one's going to have to be a negative number. I can if I make this a negative 9x. Those will add up to negative 4. Well, in order for that to be a negative 9x, this has to be a negative. But to be a negative 15, that has a negative sign, that has to be a positive 5. So again, really, what we're doing here with the factoring without the area model is not very different than the area model. It's just, it might be shorter for you. If you like the organization of the area model, this is maybe not the method that you would prefer to use. But it's just another way to factor, another way to organize the information. It's essentially the same thing. We're going to get the same answer. It's just a matter of which method you prefer.